Hi everyone, it's Coach Fred, and I'm going to be going over just kind of taking off where we left off in class, which was example B. And so we were talking about how you could tell if a set of data in a table was a quadratic model by looking at the difference of the differences. So I'm going to look at this example. It looks like I'm going, on the x's, I'm going up 2, so at a constant x value of 2. And then on the y's, it looks like, appears like I'm going down 6, down 2, down 2, and then up 6, right? I'm sorry, up 2, and then up 6. And so if I look at the difference of those differences, it looks like a difference of 4. So because the second differences were constant, it is a quadratic function. Okay, I'm going to have you look at C, D, E, and F and see if you can come up with a method by looking at the y's or looking at the equation and give a reason as to why they might be linear or quadratic. But what we're going to be looking at more today is how to use your calculator to do quadratic regression. It's similar to linear regression, but it's used when it seems like the data takes more of a parabolic model, like it's going up and then down, or it's like going like down and then up. So it's not linear looking, and we don't think a linear model is going to be the best fit. Okay, so let's look at an example. All right, so here we've got a table of temperatures in Sacramento, California. And we're going to use quadratic regression to come up with a regression model. And I said here that X was time and Y was our predicted temperature. By the way, Sacramento is the capital of California, I think. Correct me if I'm wrong, please. We got to be really careful with time, though, because remember, time, like we wouldn't put in 2 o'clock in our calculator. We would put in 14 because we're going to let X be 0 be midnight. So how many hours away from midnight? So, okay, so I'm going to grab my calculator. So let's do that. And here I grab it. And I put in the data 8, 10, 12, 14, 16, 18, and then 52, 64, 72, 78, 81, 76. If you forgot where to put that, you go to second, stat. Oops, I'm sorry, you could just press stat. Stat edit, and L1 behaves like X, L2 behaves like Y, and so then we press stat, arrow to calculate, and we do quadratic regression. Okay, and while R squared doesn't mean the same thing, let me rephrase that. R squared means the same thing as it did with linear. However, it doesn't really tell me about the strength of the line. According to Ms. Spencer, it really isn't an accurate prediction. So we're not really going to look at the R squared. We're only going to look at the model. I told you to use a quadratic model, so we're going to. So our equation then would be y equals negative 0.47x squared plus 14.72x minus 36.12. Notice I did 2 decimal places, so I stayed consistent through my equation. Okay? All right. Let's try the next one. Let's actually answer a question with it. All right. So a man throws a ball off the top of a building and he records the heights. Let me actually make this a little bit smaller so we can see it. I'm going to actually close out my calculator down here so that we have it. Okay, so he throws the ball off the top of a building, and these are the heights. And you can see that the y's are going up and then going back down. So, if you think about it over time, this is kind of what's happening. All right, so it says find a quadratic model for the data. Okay, so I'm going to grab the calculator again, and I'm going to go to stat, and I'm going to go to edit, and I'm going to clear out. I'm going to go up to L2, and I'm going to press clear. Don't press delete. Remember, we talked about that. And once you press enter, it'll go away. And then I'm going to go over here and I'm going to press clear. Don't press delete and press enter. So let's get that in. 0, 1, 2, and 3. And then 46, 63, 48 and 1. Okay, so now I press Stat, Calc, arrow to Calc, Quadratic Regression, Calculate, and there's my equation. Wow, that's a nice one, isn't it? And so that's going to give me h equals negative 16t squared plus 33t plus 46. Okay. And actually that should make sense because 0.46 is the y-intercept. So, all right, so we have some nice data here. Now it says use the model to estimate the height of the ball at 2.5 seconds. So that's saying it's giving us a t of 2.5, wants us to find the height. So we would do h equals negative 16 times 2.5 squared plus 33 times 2.5 plus 46. Now, I do want to show you this on the calculator, a nice easy way to do this. Remember when we do stat and we calculate and we do the quadratic regression, you may remember we can go to store regression equation. If you go to store regression equation, you press vars and then y vars and then enter on y1. And now it's stored it in y1. Okay, so why is that helpful? Well, today, remember, we said that if we went to second into our table setup and our table setup, our independent was on ask. Well, now that equation is in my y equals, and I can go to the table and I can ask it for 2.5. And you'll see that I'm getting 28.5 if I do 2.5. So if I do all of this calculation, I'm going to get a height of 28.5. Okay, feet. Okay, and then it says, what is the ball's maximum height? Okay, that's actually asking me for the y coordinate of the vertex. All right, so to find the y, you need the x. So we're going to do x equals negative b over 2a, which is going to give me negative 33 all over negative 32. And if you calculate that, that's going to work out to be about 1.03125. And there's my x. So I'm actually going to go back to my calculator, and I'm going to plug in 1.03125. And that gives me about 63. So I'm going to say approximately 63, maybe 0.02 feet. It's about the max. Okay, so that actually tells us that that's a really great way to use linear or quadratic regression to model some data that might be quadratic. Okay, so for now, what I'm going to ask you to do is to do the postal rates, to try that and see if you can come up with an equation. I did also assign some textbook homework that you're going to do your best on, and let me know if you have any problems, okay? Have a great day.